Okay, so in number 52, it's referring to number 42 about the difference quotient. The difference quotient is really this thing. It's the f of like x plus h or a plus h, depending on how you want to look at it. So like this minus f of a all over h. Okay, let me erase this. That's the difference quotient. So and then if I throw the limit in front, so this right here is difference quotient. And if I throw the limit in front, as h goes to 0, this represents a slope of f at a. Right? So this thing right here, the whole thing equals slope of f at x equals a. Okay. Well, let's take a look at what we have, because we should be able to interpret that in terms of slope. So if I said f of a equals root 3, and f of a plus h equals root 3 plus h, well, then f of x, I'm guessing, is root x, and a is 3. Right? So if you think about it, right, if you go back and look at this, if you kind of puzzle through it, if f of a is root 3, well then that makes sense to say it's f of 3 equals root 3 and f of x is root x. Because if I say, well, okay, let's call a 3, f of 3, let's double check. If I plug in 3 here and plug in 3 there, then I get root 3. That looks good. And then if I do f of 3 plus h, that's going to be root x plus h, which is 3 plus h. So that looks good too. So this looks right. It looks like I'm looking at the function root x when a is root 3, when a is 3. Well, that means that this limit statement right here goes with that. So it's the slope of f. So this guy right here is the slope of f of x equals root x at, oh my gosh, this pen. At x equals 3. All right. Hope that helps a little bit.